thank you very much for coming this afternoon, last session of the day, so hopefully everyone has a great evening after this. So this session is about memory management in UEFN and Creative. This is obviously a topic that's crucial to a lot of people developing on those platforms, and it's great to go through that. My name is James Golding. I'm a technical director. I've been at Epic quite a while, working on different parts of the engine, and at the moment I'm focused on UEFN and Creative in particular. So, when we say memory, we're talking about our friend, the thermometer, which is the bane of many developers' existence, but it's really important. And I wanted to first of all talk about what it is and what it isn't. So the thermometer indicates the system memory used to load your island. What it's not is an indication of performance. It's totally possible that you can have a thermometer at 100,000 with a map that runs really well. You could also have a thermometer on 1,000 that runs really badly. So it's really just about memory. It's not a specific memory value. You can't sort of directly say, oh, it's like a megabyte, whatever. When we first launched, the 100,000 represented 200 megabytes of RAM, but that has changed a little bit over time. It's increased over time, and it's something that we're always looking at. But the main reason that we care about memory is we have to have enough system RAM to load all the things that are in your map without crashing. And that's really what it's about, is we want to make sure that your map is going to fit onto all the platforms where people might want to play it without falling over and dumping you back to the screen or even exiting the application. So that's what this is all about. How do you build the best possible experience that fits within that constraint? And obviously, we would love to give people more memory. And that is, I think that goes without saying. It's something that we definitely care about. If anyone saw some of the presentation earlier on from Bjorn, it's one of these things that we're definitely interested in, we're thinking about, and over time. But we're not talking about that today. We're just talking about how do we work within the constraint that we currently have. So obviously, this thermometer measures things that you put in the map. So that's devices and props that you might place there. And the more of those you put in, the more the thermometer is going to go up. That's obviously what people are very used to and how things work. In UEFN, it also includes the custom assets that you can import. So whether that's a static mesh or a skeletal mesh, whether that's some audio that you import or an animation that you import, if those things are used in your level, they're going to add to that thermometer as well, because those are things that have to be present in memory for your map to operate. But it's also interesting the things that do not contribute towards the thermometer. And so that tends to be things that are mostly GPU-based, because the thermometer is mainly a measure of CPU memory. So you don't have to worry too much about the complexities, but knowing that, for example, textures don't actually add much to your thermometer is an important thing to know. Also things like lumen for lighting, the particle system, landscape actually, and ocean, these tend to be graphics-type features that don't affect your thermometer too much. Also, this thermometer measurement is not platform-specific. It tries to give a reading that would apply across all platforms, and so you should get the same number whichever platform you're testing on. That's not always been the case, but it's something that we're trying to get better at. And one thing the thermometer doesn't measure at the moment is sort of in-game allocations. If you spawn things, that won't be measured. The thermometer is generally measuring things, sort of baseline for your level. So another really important distinction is to draw the line between this thermometer, this memory we're talking about, and project size. That's the other, one of the other key things that you're looking at when you're trying to make a project in Creative, or particularly in UEFN rather. So let's draw a line between those two. So the project size is the size of the assets that you are uploading or downloading to the back end. So the actual on-disk size, either cooked and uncooked, we'll come to that in a second. Whereas the memory size is what's used and loaded into memory to actually play your project. Those are the two big distinctions. And you have to pass both those barriers to get your island published. So looking specifically at project size, there's sort of two numbers you're caring about. You're using the UEFN editor on your PC. You have to upload all the data into the cloud to be processed, and there's a 2 gigabyte limit on that. So that's the upload size. Then there's a 400 megabyte download limit, and so that's the cooked assets. And so this cooking process is basically making it ready for a particular platform. And so those are the two things you have to worry about here. We have this handy tool, the project size tool, that if you've used UEFN, you're probably familiar with, where it sort of does a breakdown of all of the different parts of your project in terms of how much they're using on the download size. One really useful thing is in the top right, under settings, there's an option to set that to by package, which breaks it down instead of just being this number of textures, this number of meshes. It'll actually tell you every single asset. So if you haven't looked at this, it's super important when it comes to this project size metric. But again, this is quite distinct from thermometer, from memory. This is not about that. This is about uploading and downloading. So how do these things differ? So an example would be if you add a really big texture into your project, that's going to have a big impact on the project size, the data that you're sending to the back end, the data that's being downloaded, but it will not have much of an impact on the thermometer because that's mostly measuring CPU, main memory, main RAM, not streamed textures. Textures in Unreal are streamed from a fixed size pool, so the more textures you use, things just get blurrier, they don't use more memory. So that's an important thing to think about. Reducing texture size will help your project size a lot, but won't impact your memory. Similarly, if you use Fortnite assets that are already in the game, those will not impact your project size because you're not having to download that mesh. It already exists in the application, but it will impact your memory, your thermometer usage, because it has to be loaded from that data into the game when you're using it. And so using a custom asset or a Fortnite asset, they'll have similar sorts of impacts on the memory usage, but they'll have a very different impact on the project size. So you have to keep these things in mind when you're trying to address clearing these bars. And the other thing to keep in mind is that only assets that are actually used in your map have an impact on either project size or thermometer. We try to make sure that we're only sending up the assets that are actually used. So if you have other things in your project, you imported them, you decided you didn't want to use it, you don't have to worry about like deleting absolutely everything that's not used. It'll just not be uploaded to the server. So the other thing I wanted to talk about, one of the key sort of concepts when you're dealing with memory is instances and assets. And what does that mean? Well, we talk about an asset as some shared resource, like a mesh, which can be used multiple times in your level. That tends to be where most of the memory goes. So you might have some mesh that's used that's maybe using 300 units of your 100,000. And then you have a number of instances that reference that use that data. And each one of those tends to be quite small in terms of usage. So what does this mean in practice? Well, what it means is when you first add an instance of a mesh, you import a mesh, or you decide to use a Fortnite prop, you place one of those in your level. Suddenly, that asset is now being loaded and is now being counted against your overall memory budget. So the first time you add one, you might see your thermometer go up by, say, 302 in this case. 300 for the asset data that's going to be used, and 2 for the actual instance. But the next time you add one, it'll only go up a tiny amount, because the resource is already referenced, it's already loaded, and the actual instance cost is quite low for each one that needs to be added. So that's why reducing the number of instances of something doesn't necessarily have a big impact on memory unless you get rid of all of them and that asset is no longer used. And the way that assets get loaded in Unreal is sort of recursively. You might have a prop that references a mesh, the mesh might reference a material, the material might reference some textures, and that whole lot of things gets loaded as a result of that prop wanting to use that mesh. And so this is really important when you're thinking about things like devices like vehicle spawners, which can use a huge amount of memory. And the reason they do that is because they have to reference the vehicle mesh, they have to load in all the materials and textures that were on those things, but they also have to load in particle effects, they have to load in audio, they have to load in custom animations for that vehicle. So there's this whole cloud of assets that gets loaded in as a result of putting down just one spawner. But then when you add the second spawner, that'll only add maybe 20 or 30 to your thermometer. So it's really about these shared assets that you need to be thinking. There's a really handy tool in the editor called Reference Viewer, and you can right-click on any asset in the content browser and say Reference Viewer, and it will show you this neat graph which explains both what it's being used by and what it's using. And this can be useful if you're trying to figure out, like, well, why is that thing being, ending up in a project if you're looking at project size or something like that? Like, how is this thing being pulled in? This can be a really useful way of finding, why is that texture referenced, or why is this mesh being pulled in? You can sort of see from both sides. This will show like instances in the level and things like that. There's also a panel, if you go to Tools on the menu and go to Audit and then Statistics, you get this statistics window which shows all of the actors in your level and the assets that they reference and how many of them there are. So this is really useful if you're, again, trying to find that errant reference to an asset, a mesh that you'd rather not load. You can sort by the count of times that asset is used, find that, that's that one. If I just get rid of that, then suddenly that mesh goes away. Or maybe I can use a different mesh instead of having to use that particular one. So one thing to keep in mind is that this isn't, these numbers here don't directly equate to thermometer numbers, but at least it's a good way of understanding what's in my map, what's being used, what can I maybe get away with, keeping things a bit more compact. So a really useful tool in your battle against memory is streaming. In creative mode, there's sort of an automatic streaming that works on props and devices that are near you. Not all devices support this sort of streaming. Some of them are loaded all the time, and that's something that we can talk a little bit about more later on. But the idea is you're sort of using sort of network relevancy so that things that are far away disappear, are unloaded, things that are near you are present. It's automatic, it's dead simple, you don't have to set anything up, but you get this sort of pop-in effect. You don't have a lot of control, and things sort of pop in as you get closer. I think a lot of people who've built complicated or large maps in Creative are familiar with that. And there's this handy spatial thermometer, which lets you see what is the memory usage all around your map, depending on what is in that area and what is actually going to be loaded and in memory for that point. But UEFN adds a new tool called World Partition. And this breaks your map into cells on a 2D grid, and cells are only loaded when they're near the player. So this is a sort of spatial-based streaming system, and only the stuff that is in loaded cells is actually contributing to your memory usage. So this lowers the sort of high watermark that you'll get, because rather than everything in your map being loaded at once, only stuff that's nearby, and as you move around, some stuff gets unloaded, some stuff gets loaded, and so you'll see the memory actually sort of go up and down as you move around in the map. And people are pretty familiar with this from big open world games. This has been done for a long time, but you can do this inside UEFN when you're building large maps. This is one of those things that you sort of want to think about at the beginning of a project. It can be quite hard to turn this on right at the end. It's good to think about, okay, do we have a large map? Are we going to be able to spread things out? And turn this on at the beginning and then start working with this system early on. One thing I should mention, there is, to turn this on, you flip the enable streaming option in the world settings, which is off by default. So there is an option on every object called is spatially loaded, and you can turn that off. It's on by default. You can turn that off for things that you don't want to be loaded in that way. So in this case, where we've got these distant mountains, we don't want those to be unloaded at some point. We want those loaded all the time. They're part of the background. So you can have those opt out of this sort of world partition spatial loading system. And you have some options. You can control how big these cells are and what range you have to be within for them to be loaded. And you might want to tune that number based on the size of the world, how dense the objects are packed in, how fast you're moving across, because obviously when this is actually loading data, it takes a little bit of time to do it. So if you're shooting through the world very fast, you might need a little bit more time. You might have to load them a bit earlier. So these are numbers that you can tweak. There's a handy option in these settings, inside world settings, called preview grids, and that shows this nice kind of overlay on the level where you can see as you move the camera around which cells would be loaded from that camera position. At the moment, in the editor, all cells are loaded all the time. There is an option you can turn that off if you want to just load in certain cells to preview how things look. But to make it easy, we generally, in the editor, load cells all the time. So what about cells that are unloaded? Do you just see a big hole? Well, you don't. You use a thing called HLOD, which stands for Hierarchical Level of Detail. Fancy title. And the idea here is it's a low-poly replacement for a cell when it's unloaded. You can just choose Build HLODs in the editor, and it will go through and automatically generate a low-poly version of each chunk of your level, and that's what's going to be used whenever a cell is unloaded. So you don't get the full detail, but they look pretty good from a distance. This is exactly the system we use in BR at the moment. But do remember that when you make these HLODs, those become unique meshes, unique textures that are loaded all the time, and are also part of your project, which will add to the project size that we talked about right at the beginning. So there's a little bit of a trade-off there. You are going to see some extra assets added to your asset to your project when you turn this on. But again, it's really important for being able to have distant objects that you can see. And this sort of works around the pop-in problem that you see with normal creative streaming when you get close to things. So it's great to have a big map and see distant landmarks all the way on the other side. And here's an example of the HLOD that you might get. On the top is the sort of fully loaded, detailed, made up of lots of different objects. And on the bottom is a single object that's been made out of those that's sort of the replacement. You'd never get this close normally to have that visible, but it just shows kind of the work that it's doing in terms of automatically building a stand-in for you. But there's another tool you have as well with streaming. We have a tool called data layers. So how do these differ from streaming? Well, they both control what's loaded and avoid you having everything in your map loaded at one time and therefore blowing your memory budget. They're something that can be used in the editor or at runtime, but the key difference is they're controlled by game logic, not by location. So rather than where the player is controlling what is loaded, you get to control it through gameplay logic set up through devices or scripting. So the way you use these is you create a data layer asset, and then you can choose any props in your map, and you can assign that asset to it, which basically says, oh, OK, this prop belongs to this data layer now. And then in the editor, there's a data layer tab, which will list all of your data layers, and you can hide and show those as you wish with a little eye. And you can show, so it's kind of useful as an editor tool to be able to like hide sections of the map. You can imagine situations where, for example, you might have a room or a section of a city which starts pristine but then gets flooded or destroyed. You could have those as two different data layers, and you could hide one and show the other one, but never having both at the same time. You don't have to have a whole bunch of hidden stuff that's taking up memory. You can just choose different ways you can build interesting gameplay scenarios where you come back through the same environment, but it looks different each time by hiding and loading data layers. There's 3 settings for a data layer. Active means it's loaded and it's visible. Unloaded means it's loaded but not visible, and unloaded means it's not in memory at all. So the top 2, it will be taking up memory usage, and then in the third one, it's not taking up memory at all. This is a project that we worked on to show at Unreal Fest this year called Lunar Horizon, but we use data layers heavily for this. In this project, it's a collaboration with the European Space Agency, where we looked at one of their concepts for a moon base, and the players have to basically build out all the extra sections by gathering resources. And each section was done as a separate data layer. And so when they had the resources, they could press a button, and we could just load that data layer in, and a new part of the base appeared. So it was also dead easy for the designer to go and basically see what this is going to look like in the editor just by turning layers on and off. So you have to choose with the data layer whether it's set up as editor only, which is how it works at the moment. In that case, it just all gets baked together before it gets sent out. Or you can change it to runtime, which means it can be loaded dynamically on the fly. And that's what we're talking about. Right now, you have to use sequencer to load and unload data layers. There's a special data layer track you can add to a level sequence, and then play that sequence, and it will cause that layer to be loaded or unloaded. But we are going to add support directly to Verse, so Verse will just be able to go, hey, load this layer, unload this layer, and have some really direct control over setting things up. So really powerful tool, definitely worth checking out if you're building maps which are dynamic or where you don't want to avoid loading stuff all the time. Okay, memory calculations. So anyone who's tried to publish a UEFN map knows that you have to pass this grueling test of memory calculation before you're allowed to publish it. This runs inside the UEFN editor, and it checks the memory in-game. If you're not using streaming, it's really quick. You basically have to go through a process of, there's a few steps to it, but you run the process, it tells you, you get a box like this that gives you a success or fail. In this case, I've clearly well optimized my map, looks great, and you get a result. If you've got streaming, it takes a bit longer. It can take up to an hour, depending on how large your map is, how many streaming cells you have, because it has to teleport to each cell in the map and see what the memory is there. A bit like that spatial thermometer we showed earlier on. So you have to check the check the docs for the process. There's a few things you can do to make the process faster. Having things that are set to spatially loaded, turning that off for things that don't need to be, that'll make it faster. Avoiding objects that have really big bounds that stretch across the whole map, that can help as well. And just playing with that cell size, like we talked about earlier, to reduce the number of cells can make it faster. And once you've done the memory calculation, you get a very attractive report in the message log under memory test results. And this will list the top 100 things in your map by their thermometer contribution. So really helpful place to start when it's like, oh my goodness, I'm over budget, 20 or 30,000 over. What on earth am I going to do? Rather than just randomly deleting things from your map, you can use this to understand what are the biggest contributors to that memory. And I want to talk through what this thing is, because if you're trying to optimize memory, you're probably looking at this quite a lot, and the columns aren't completely obvious. So I've got some hopefully useful diagrams that explain what's going on. So like we talked about earlier, you've got assets and you've got instances. First column is just the name of the object in the map. Shared asset means any assets that are used by more than one thing in the map. Exclusive assets means an asset that's only used by that object. So if you've got a particular mesh you put down, it's only you could have multiple instances of it, but if it's only used by that prop, then it counts as exclusive. The per instance min and max are the actual cost for each instance of that thing in the map. And so like we talked about earlier, generally the mesh is the expensive bit and the instances are quite cheap. So you can see on like the second row here, the mesh itself is like 3,121, but each instance of that mesh is only 2. So I can go putting lots of instances of the mesh around, it's not going to have too much of an impact. Number of instances is the number of instances of that thing in the map in total, and total exclusive is the number of instances plus the cost of the actual asset. So that's kind of like the total cost of that thing, including its asset, and then the total includes shared assets as well. So this is a little bit more confusing because it's sort of double counting any asset that's used by more than one object. What I found quite useful is you can take that, copy the whole thing, paste it into Excel, and there's a handy text to columns conversion, which then makes you a nice table. So you can sort it by the different columns. So if you want to say, OK, what are my biggest assets? Sort by that column. If you want to see, OK, what have I got the most instances of? That's another column that you can sort by. So where are we going with all this memory tracking stuff? It's obviously a major constraint on what you can build and something that we take very seriously when we're trying to make better. So there already is an improved thermometer calculation in 2620. It should be more accurate and more accurately reflect some of the different props and devices that are in the game. And it should be more deterministic as well. There were lots of issues before where running it on different people's computers or different times, you get very different results. And hopefully a lot of that has now been fixed. So at least you've got a more reliable baseline that you can work from. We'd like to try and speed up that memory calculation. In the cases where streaming is on, it can take a long time, and that's not fun for anyone. We're continuing to try and make devices more efficient, looking into why do certain devices use so much more than others. Are there maybe things we can change there? Like I mentioned earlier on, because it does this recursive loading of all this data, sometimes just a single reference can cause a whole island of content to be loaded. So we're doing some investigation to try and make that better. And like I mentioned, we're trying to figure out like this memory limit in general. We've been creeping it up over time. Are there things we could either optimize and give you more, or maybe make things more opt-in, so that systems that you're not using in your game, you could opt out of and get the memory back to use for something else. But that's a little bit further out. We're also going to make streaming better. So one of the big things that you don't get in UEFN right now, but you do get in Creative, is that spatial thermometer. So we're going to be building a new tool which allows that sort of spatial view of memory across your whole map to be possible right in the UEFN editor. And we'd like to make this also so you can actually run through your map, record data, and then load that into the tool so you can get data right from playing the map. We'd like to add support for a 3D grid. At the moment, it's only, like I mentioned, a 2D grid, but if you're building a map which has a lot of verticality or multiple floors, you might want a 3D grid, so you're loading stuff as you move up and down in the world, not just on the X and Y. We'd like to have better preview for HLODs in the editor. It's quite hard to see how they're looking and how well they're working at the moment, and that's something that we'd like to make better. And also having world partition bookmarks that just makes it easier to deal with complicated setups where you can just have pre-configured setups you can just jump to. And also, like I mentioned earlier on, only some devices support streaming at the moment, continuing that work so that devices can be streamed in and out. So I wanted to talk through a few specific problems and solutions. If you're seeing a particular issue with a particular kind of asset or things going on in your map that are really causing you headaches with memory, I wanted to talk through a few sort of common solutions. One thing I highly recommend is going to Julian's talk tomorrow on project optimization in UEFN. He worked closely on the Nike Airforia map, and he's giving a talk tomorrow morning where he goes into not just memory optimization, but also project size optimization and performance optimization with some really good sort of practical tips. So highly recommend checking that out tomorrow if you're looking at making your Fortnite creative projects run well and fit within budget. So device memory, that's a really common reason that you might blow your budget. So there's a few things you can do. Knowing that it's mostly the assets being loaded by those devices that's the problem, you can sort of spread them out and use streaming. So like in this section of the town, I have one set of devices. Again, if they support streaming, I can sort of stream those out and have only a limited number actually loaded with all their assets at any one time. Again, reducing the variation of devices, or instances, that's supposed to be more instances. We're not mining here. But again, having lots of instances of a small variety will be less memory intensive. Also, there's now the opportunity to start using verse a bit more than devices for sort of common logic things. For example, HUD message devices, you can change the message on a HUD message device from verse. So you might need just one of those in your map and have verse that changes what the message is before you show it. And so there's lots of cases where you can actually cut down a lot of logic and things that was being done by devices before and use verse for more of that, which can just reduce the number of them that you need. And again, just looking at similar devices, so again with vehicles, they vary hugely. I think the cheapest vehicle is about 250 and the most expensive is about 14,000. So just trying out different vehicles and seeing what, and different sorts of devices to see what actually impact they have. Just put one down, see what your impact is and make choices based on that. Okay, so let's say you look at your memory calculation profile and you see that meshes are causing a problem. How do you reduce the memory impact of these custom meshes that you brought into the project? Well, obviously, the easiest thing is just to make sure that the polygon count is sensible before you import. You probably want a few thousand, but not probably tens of thousands or hundreds of thousands on a mesh. So having a look at it before you import is definitely useful. So let's say you've imported it, and it's already, you've got a bit of a problem. So what do you do then? There are some nice options right in the static mesh editor which let you tweak that. So there are some options on the right-hand side. You can see here after you open the mesh. So here's a really complicated mesh that is probably too high poly and needs to be reduced. there's an option for nanite percentage and also fallback percentage. It's the fallback one that's probably more important. Nanite is streamed in a similar way to textures, so nanite poly count is less of a problem on thermometer, but that fallback one, that's the one that's loaded all the time and used on platforms that don't use nanite, is probably the one that's going to have more of an impact. So have a play with those numbers, reduce the poly count to the point that it doesn't visibly have an impact, but that can save you a fair bit of memory. Another really handy tip is that the collision data for a mesh can actually add a decent amount to memory. There's an option on each section of a mesh called Enable Collision, which turns off all collision for that, and so it won't even load the collision data for that section. This is also useful for things like a tree, where you might want the trunk of the tree to have collision, but the leaves to not have collision. So you can turn that off, and that allows, that turns off collision so players won't collide with the leaves, but only collide with the trunk. So there's some gameplay benefits for that. But also, if you've got a mesh in your project that you're using for, say, a God ray or some particle effect that you're never going to need to collide with, just turn that off, and the mesh will be a lot cheaper. If you do need collision on it, but it's a nice high poly complicated mesh, and you don't need every visual triangle to have collision, you can choose a lower LOD of the mesh to be the complicated collision for the object, and that's the LOD for collision option as well. And then another thing is just to make use of the meshes that you have. This is just one mesh that's been scaled non-uniformly, had some different materials applied to it. I'm certainly no artist, but the idea is just to say you can pick a mesh and actually find lots of different ways to use it by rotating, scaling, changing materials. And that, again, gets the most mileage possible from any of these assets that you're putting in. What you're trying to do is have the minimum number of assets, but then use them as much as possible. That's the most memory efficient way to build stuff. And so what do you do if you have just too many instances of something? I've seen some maps which had maybe 5,000 to 10,000 instances of the same mesh all over the place. Maybe it was a railing, maybe it was a vent or a window mesh or something like that. And in those cases, it's actually not the cost of the asset that's the problem. It's the 2 or 3 units for each instance that's the problem, times by 5,000 instances. So how can we make this both render faster and actually use less memory? So you can convert into what's called an instant static mesh component, or ISM, or even more excitingly, a hierarchical instant static mesh component, or HISM. So what are the pros and cons of doing this? Well, the pro is that it uses a bit less memory and it's more efficient to render, which all sounds great. What are the cons? Well, you can't interact with it anymore. You can't use Fortnite props for this. This is only suitable for custom meshes you brought in, and they're just going to be rigid parts of the world. They're not something that you can then manipulate anymore. Julian does a better demonstration of this than I can go into here, but the basic gist is you add an empty actor, add one of these HISM components to it, stick a static mesh in, and then you can add lots of instances to it. And so this is a way of adding lots of instances to your map in a very efficient to render and memory efficient way. So if you're building a map with lots of instances of the same mesh, really useful technique to know, and is definitely the more efficient way to render it. And definitely check out his talk tomorrow where he has some videos that goes through the whole process. Audio is another thing that, if you've got really big bits of music or things like that, you might have some big assets. You can loop shorter sounds, and you can also combine short sounds together in sequencer. It's a really good way to put sounds together. I looked a little bit into compression settings, but we use Bink already for that, and that actually has some pretty powerful compression already. I wanted to call out billboard devices. If you're not already aware, these can be really heavy on memory because each unique billboard has to allocate a texture that has to be loaded into main memory to put the text on. So unfortunately, it's one of those things you just have to be a bit aware of. The resolution multiplier, which changes the resolution of it, is the main thing which you can use to control. And obviously, putting those and streaming them is going to be better than having them loaded all the time. So what's the conclusion after all that? Well, the most important thing to remember is what the thermometer is all about. It's about, will your project load without compromising the program? So it's not about performance, it's not about download size, it's just about that metric of, will it load? You can use these tools like streaming and data layers to make sure you're only loading what you need when you need it. And you can also use tools like the reference viewer and the statistics panel to make sure you're only loading what's actually necessary. I've certainly seen over years of game development, one super high poly mesh that someone put in and then forgot about and moved underground and you can't even see it, or a tub of earth that has 40,000 triangles in the corner in a pot because someone likes a really detailed bit of earth in there. Or they used a landscape they just made tiny to fill in this corner. And so you need to track those down by using those tools. And just learning about what affects the size of assets. What's an appropriate size? How do we make sure that there's not some crazy asset that's just blowing your budget in some way? So thank you very much for coming along. That covers what I want to talk about today. Enjoy the rest of your evening. Enjoy the rest of the show. And really great to have you all here. So thank you so much.